Today we're going to talk about parallel arrays, and here I have set up two of them. We have the first array here whose name is cookie, and I set that up by saying here string and then the square brackets cookie equals new string 4 because there are 4 elements in this array. And they're going to hold strings. They're going to hold the names of the cookies. And incidentally, I put the names in right down here. So cookie 0 is chocolate chip, cookie 1 is brownie, etc. 0, 1, 2, and 3 are the indices of the elements in this array. And then we have another array, a second array, whose name is price. I set this up here. It's an array of doubles, 4 doubles. And then over at the bottom right here, I put the price, I set the values. So price 0 is 1.25, price 1 is 1.50, etc. And when you have parallel arrays, they are usually the same length. You'll see here the length of each of them is 4. And the idea is that the idea here is that a chocolate chip cookie costs $1.25, a brownie costs $1.50, oatmeal raisin costs $1, and a fig bar costs 75 cents. So again, one array to hold the names, and these are all strings, initialized, declared the array here, array of 4 strings, initialized it here, that means put the values in, declared our second array of doubles, and initialized it here. So I've set up these 2 arrays. Now I'm going to ask my user to give me the name of a cookie, and I will take in the name of that cookie, and let's say it was a brownie. So then I'm going to search this array until I find the name, the string brownie. And when I find it, I'm going to note the index. Okay, I find it at index 1. And that tells me that the cost of a brownie, or the price of a brownie, can be found at price 1. If the user entered fig bar, I have to search my array until I find fig bar, and then I find that it is at index 3, which tells me that its price, the price of a fig bar, I can find at price 3, which is here. So I search my array of names until I find the name I want. When I find the name I want, I make note of that index because its price is in this array at that same index. So let's go to NetBeans. Here is where we set up these 2 arrays. We created these 2 arrays. And here we initialized the values in the cookie array, and then we initialized the price array. So now we've set up our arrays, and then we ask our user for the name of a cookie. And I get the name of the cookie from the keyboard. Now it has to be next line because some of these cookies have spaces. So oatmeal space raisin. If I say next and not next line, I will get oatmeal, but I will not get oatmeal space raisin, because next stops at the first space. So I need next line to get my cookie name. I'll talk about this index equals -1 in a minute. We have a for loop. We're going to look in our for loop for the name that we just got from our user, the name of our cookie. And I'm going to bring this up here. Supposing name was brownie. So k starts out at 0. If name dot equals cookie 0, well, cookie 0 is chocolate chip, and that's not okay. And that if statement is the only thing I have in my for loop. So I hit the end of my loop, go up to the top, k becomes 1. So if name is cookie 1, well, cookie 1 is brownie, name was brownie, so it is equal. Let's see what we do. We grab hold of that k, so index is now k, which was 1, and break. That breaks us out of our for loop. Why break? Because I don't want to search any longer. I just found brownie. I don't want to keep going through this array to find out if I see brownie again. I found it and it's only there once and I got it. Break out of the loop. And now I'm ready to print something, and I'm ready to print the cost of 1 brownie cookie is price index. We just said index was 1. Index was k from line 30. So that was a 1. What is price 1? Price 1 is here, $1.50. So I found brownie in my top array. I grabbed hold of the index, and then I used that index to give me the price in my price array. Couple of things we can do here to make it a little bit better. Let me make this a little bit bigger. Supposing the person gives us something that wasn't in the array. So let's imagine that our user says butter. I want a butter cookie. And we don't find any. So we go round this array. So we go round this loop, and when we get out of the loop, we have not found a butter cookie. But here on line 27, we set the value of index to be -1. So we can stick an if statement in here. So if my index was -1, that means that it never got reset in this loop, which means we didn't find it in our name array, in our cookie array. So we can say, okay, sorry, we don't have that kind of cookie. Otherwise, we'll print out the cost of a cookie. So let's try that. So I'm going to try butter. Sorry, we don't have butter cookies. I'll try one that we do have. Oatmeal raisin. I think it was raisin oatmeal. Okay, let's try a brownie. And let's try, make sure it was oatmeal raisin. That's because raisin is uppercase R in our array. So if I say oatmeal raisin, it will work. Maybe it would be better if I say here, if it equals ignore case, because then if our user doesn't get the case correct, oatmeal, it will still work. Our second example on parallel arrays is this one. We have several Girl Scouts selling cookies. We have an input file that lists the name of the girl and the number of cookies sold each day. And we want to output the name of the Girl Scout who sold the most cookies and the name of the girl who sold the second highest number. I'll show you the input file. So we see a string with a name, a single name, and the number of cookies sold. We set up two arrays, our parallel arrays here. One is for the names, one is for the number of cookies sold. You'll notice I call them name array and count array. This was merely so that when I'm programming, I don't get myself confused, whether it's a single name or it's the name of the array. So you don't have to call it something array. I just chose to do that. We have 4 Girl Scouts. Therefore, our array is of length 4, which means that our indices go from 0 to 3. Biggest mistake students make is thinking, well, it's of length 4 and therefore my index goes from 0 through 4. This is not true. 0 through 3. And we have an array where we were going to count the number of cookies. So for instance, if Frankie sells 20, we're going to add 20 to this total, and then if Frankie sells another 30, we're going to add another 30 to this total, getting 50. So we're going to start these out at 0 and then increment them as these Girl Scouts sell cookies. The number that goes in this first element of count array is the number of cookies that Frankie sells. The number that goes in the second element, the one with index 1, is the number that Janet sells, etc. So the first thing that we have to do is set up these arrays. And we're going to go to NetBeans. We're going to get our input from a file called cookies.txt, and this is the standard way of setting up for an input file with our try catch. Lots of students try to do everything at once, but that can lead to disaster. It can lead to a lot of errors, and then trying to unravel those errors is tough for you and tough for the tutors. So I always suggest that you start with something simple, something that works, and then build on that. So what I did here, while scanner.hasNext, pick up a name, pick up the number, print it out. And let's verify that we can actually get all of our output, all of our input in and read and output. And if I look here, I know that the first one is Janet with a 45, the last one is Abby with a 20, and if we get that, we presume we got the ones in between. So we'll print this. We will look at our output, and we will see that we got Janet 45 and we ended up with Abby 20, and we're going to assume that we picked up everything in our input file, and first hurdle done. Now I need to worry about setting up my arrays. So here I have set up my arrays, and I've also put some comments in here for you for reference. Here is my count array. it's an array of ints and it is of length 4. But I also said that Java initializes the elements to 0. You remember we wanted them to start out at 0. But not all languages do this, and if you don't know whether your language that you're working in does it or not, you probably need a for loop, because your language probably has a for loop, and you want to initialize everything to 0. Java and some other languages, I know C++ does this, allows you to initialize as you declare. So here we're saying, okay, we need an array called count array, and I want to put 4 zeros in there. You'll note it's quite different to line 27, where we have to say, well, I need 4 of them. Here, by default, you're getting 4 because you're putting 4 zeros in there initially. So that's my count array, declared and all initialized to 0. And now I want to deal with my string array. So here I am declaring an array that can hold 4 strings, and here I am initializing them. We saw on lines 32 and 33 that we could actually initialize as we declared, and we can do that here. We can say string array name array equals and then put them straight in. So that's probably a little easier. It saves you 5 lines. You can do it all in one. However you do it, we now have our 2 arrays set up and initialized. So if we go back to here, we're at this stage here. We've got them all set up. Let's take care of one of them. And I know that the first one in was Janet. Janet sold 45 cookies. That was the first name on my input file. And if I forgot, I can look back here in my output, Janet 45. So I'm just going to deal with one piece of input, the first line, and then I'll worry about all the rest. But first, let me do one. So I'm going to get the name, and I'm going to get the number. And now, just as I did before, I'm going to head into a for loop because I am going to search my name array. And my first name was Janet. K becomes 0. If Janet dot equals ignore case, name array is 0. But if I look back, name array 0 was Frankie, so I know that that wasn't true. And that's the only thing that I have in this for loop. I put the curly braces in. Truly, you don't need any of them because the whole for loop just consists of one if statement. There is no else, there's only an if. And now K is 1. If Janet dot equals ignore case, name array 1, and if I look back at name array 1, it was Janet. So I did find it. In that case, I want to increment my count array 1, add to it number. What was number? Number was the number of cookies that she sold. It was the 45. This is the end of my for loop, but I really would like to know that I did that correctly. So I threw in another for loop here. That's a complete for loop because it only consists of one thing, which is a print line. So I'm going to print out name array 0 followed by count 0, and then name array 1 followed by count 1, etc. And if I run this and look at my output, I see Frankie 0, Janet 45, Sam 0, and Abby 0. So nobody sold cookies except for Janet, which is correct because that was the only piece of input I took in. It was the first line in my input file. So now I know that I can do this for one line in my input file. I need to do it for every line in my input file. But the question is, what is it I need to do over and over again? It isn't this output. That I just do one time at the end. But over and over, I do this. Take in a name, take in a number, search my name array for that name, and if I find it, increase my count array. So that's what I do over and over again. When I find that, I put curly braces around it. So this is what I am doing time after time after time. And then I can stick my while loop in here, while scanner.hasNext, which says, as long as I've got input, do something. Do what? Do from line 46 to line 56. Let me run that. And now I see that Frankie sold 221, Janet 201, Sam 181, and Abby 158. So far so good, but what I need to do now is output the one who sold the most and the one who sold next to the most. And looking at these numbers, I know that my answer should be Frankie and Janet, but I got to get there. So that's the piece that I do next. We saw in the previous output that Frankie had sold the most number of cookies. But I want to be sure that I am traversing my array looking for a bigger number. And so I altered my input file a little bit to give Abby a boost. And so now when we look at our names and totals, we see that actually Abby is going to have the most number, and then Frankie will have the second most. So I altered my input file in order to get this, so that I can test my program. So the program right now, I did put in a header and a line in my output file saying names and totals, and printed a blank line here, and then put the names and the totals in and another blank line, and that's where we were up to just now. Now I want to find the biggest number, and there's a very traditional way of doing that, and that is to say that the biggest is the very first elements in the array. So I'm looking in my count array in order to find the biggest number. I'm going to look through this array. So I'm going to start out by saying whatever number is in here is the biggest. And then I'm going to look in here. Well, right now I've got zeros in there. So let me go back to here and see what my numbers are. 221, 201, 181, 258. So I start out by declaring that this number here, this 221, is the biggest. And then I look at the next number. Is that bigger than the biggest? No. Is this bigger than the biggest? No. Is this one bigger than the biggest? Yes. Okay. Hang on to the index, because I need to go and find that same index in my name array to find out that Abby sold the most number of cookies. So biggest is the number, that's in my count array 0, the first element, and then I'm going to start at index 1 and go up to, but not including 4, and say, okay, if that number is bigger than the biggest, then my new biggest is whatever that number was. I also have to grab hold of my index. I have to grab hold of the K. I don't want to break because I might find that the next element, in fact, is bigger. So there's no break in this 4. I have to go right through my array looking for the biggest number. When I get out of there, okay, name array K, so I find the name and the number. I could just write biggest here, but it doesn't make any difference. So now when I run this, I find that Abby had sold 258 cookies. So that's the biggest. My job now is to find the second biggest, and there's a few ways of doing this, but the easiest way would be to set Abby to 0, because then I would not be able to find this one again. I mean, it would not be larger. So if I set the number of cookies that Abby sold to 0 and then look to see who's the biggest in here, I would find out it would be Frankie. And that might be the easiest way to do it, but it's certainly not the only way to do it. Now we're looking for the second most number of cookies sold. We set Abby's number to 0. Index was the index of Abby, which was 3. I'm going to set it to 0 so that I do not find Abby the next time around. If I look at my plan here, I'm going to make this now 0. And I'm going to start at the beginning and say, okay, this is the biggest, check to see if this is bigger, and check to see if this is bigger, and check to see if this is bigger. Because that's a 0, it will never be bigger. I will not find it. So I set Abby's, so I set the largest count to 0. I need to set my index back to 0. I started it out at 0 on line 63. It became 3. And now I need to set it back to 0 again. And then I can literally copy this code here, because now I'm again looking for the biggest. And I can print out the second most number. And if I look at my output here, I find that the second most number was Frankie, which is correct. Let's just give Sam a boost and make sure that we can find Sam. Let's Okay, so Sam was the most number, and then Abby was the second most now. So it looks like our program works nicely.